In this chapter, we'll be working on the landing page in order to sell our course. We'll be looking at ways that we can optimize the speed of the landing page by using static assets and optimizing our images. We'll also look at how we can pre-render our page so that we're not rendering it every single time a user visits. And we'll also explore how we can integrate Stripe into our checkout process so that we can finally get paid for all this work that we've been doing. By integrating with Stripe, we'll be able to create a system where we grant access to only those who have actually paid for the course. In this lesson, we're going to take a look at static rendering and pre-rendering for our Nuxt app and see how we can use that to make our landing page blazing fast. So since the last chapter, I have added in some code for our landing page in order to get us started. It's not really focused on Nuxt specifically, so I decided to skip over that part. But I do want to show you what I've been up to so that you can get on the same page with me here. So I've added a bunch of different things. In our components, I have added a badge component, a loading indicator, a pretty basic modal component, and then the payment component that we will later use to hook up with Stripe to actually get paid, because that's important. And I've got this section component, which we use in the landing page here. And those are the different components that I've added. We'll see how they work in just a moment. I've also added in this landing page here for us, and that's the important one here. So let's take a look at what we've got with our landing page. We have a hero image here at the top, along with this buy button. And this buy button triggers a modal with a checkout component or the payment component that we've added. And right now this does nothing because we have not hooked it up with Stripe yet, but we can see that we've got this button here and we can open and close the modal as you might expect. And as we scroll down, we can see that we've got some high-level bullet points of the different features and some screenshots with a bit of a hover animation just for fun. And then at the bottom of our landing page, we have our course outline. We're reusing that component that we use for the bullet points, but instead using it to show the number for the outline here. So in the code, this is using a section to just deal with the styling. So we see that we alternate between white and blue sections here in the code, and that's exactly what the section component does. So let me give you a quick little overview here. It's basically just some styling with a header tag and then a slot. Nothing too interesting, but if you want, you can take a closer look at that on your own. Then we've got the button, which triggers the modal. And the way that we've set this up is we have our show payment ref here, which is initially set to false. And then this button will just toggle it. If we scroll down to the bottom of our page, we see that we have this payment component here. In the payment component, we put a VIF if the show payment is true. And then if the payment emits a close event, then we set it to false. So we close that modal. And so if we take a look at what this payment component is actually doing, we can see that we've got a modal component and then a bunch of styling. We've got our form pre-written here for our checkout process. And so that's all that this is doing here. It's basically just a bunch of markup inside of a modal. So let's take a quick look at the modal. This modal, we've got some styles to blur the background here to give it a nice little faded look here so we can separate the background from the foreground element. Then we have the close button in the top right corner that we've implemented, which is right up here. And then we've just got a slot to render whatever content we want. The more interesting part of this modal component is that when the component is mounted, when the modal is displayed, we do a bit of work to set the overflow on the body to be hidden. And that prevents us from actually scrolling when the modal is open. So if we scroll all the way down like this and we hit the buy button, we see that it opens. But if I try and scroll, it won't scroll because we have this overflow set to hidden. And then when the component is unmounted, we just restore whatever value we had set previously. And this makes it possible to have the modal take up the full screen without us accidentally scrolling the page behind it, which is a little bit annoying. Now, if we scroll down further, I'm just looping through an array of different learning outcomes to render this section here, along with a badge component that just has some basic styling to get this checkmark going. Then we render all of the different images in our screenshots for the screenshots section, along with some styling for the animation here. And then finally, we've got the course outline at the bottom. And this course outline, we actually grab this outline from our course metadata endpoint because we've already got that data. There's no need to hard code it. And so we fetch that data, and then we can just, similarly to how we do it for the nav bar in the actual course application, we can just loop through the chapters and the lessons to render out our outline. And so that's what this code over here is doing. The script here is pretty straightforward. We have our use course to fetch the metadata. We have this hard-coded array, the learning outcomes, another hard-coded array for all of the screenshots that we've got. And then one important piece, which I have not mentioned yet, is that we actually use layout false to remove that default layout because we want to start from scratch with our own styling on this landing page. We don't want it to look the same as the rest of the course platform looks. So that's a quick overview of the code that we've added since chapter 6. In the next lesson, we'll take a look at how we can use static generation and pre-rendering in order to make this page blazing fast. In this lesson, we're going to take a look at how we can use static generation and pre-rendering in order to make our landing page really fast. So the main problem that we have with our landing page right now is that we're generating it every single time a user comes to our website. Because of the way that universal rendering in Nuxt works, we are rendering the page on the server side for every single request. And we're doing that work over and over and over again. Now, while that makes sense for our course platform, this is the same page every single time a user looks at it. We're not changing this page very often at all. And so we might as well just build it once at build time. And once that's been rendered, we can just serve up that same HTML over and over and over again. So Nuxt comes with a command that lets us pre-render our entire website. If we run pnpm generate, it will go through and render all of the pages for us. So here we can see in the console the output of the pre-renderer. We start with 6 different routes, and then as it crawls through the routes, it finds the rest of the routes. We've got 3 lessons here, and then it generates all of the different JavaScript payloads that are needed to go along with that HTML. You may notice that there are only 3 lessons in the output here, and there is a very good reason for that, which we will get to in just a moment. But first, let's start up the server and see our built website. If we go into our package JSON, we can see that we have a bunch of different commands by default. And so we just used this generate command, and now we're going to use the preview command. So we'll run pnpm preview. We'll let it install a package. And now we're running at the same port that we were before. So we can actually just refresh what we were running from our dev server, and we can see all of the different activity that we've got. So we see that our page is being loaded where we've got all of the different things. We're loading the different images. We're loading some of the payloads as well. And if we click around, the website works. If we go to our main page, we can see that we've got this link here. We can go to our first lesson and everything loads. We can click around among these lessons and it all generally seems to be working fairly correctly. You'll notice that we've started to get a few different 404s here in the console. So if I click on chapter 2 here, we'll see that it brings us to the login page, which is all fine and dandy. That's exactly what we would have expected. But once we click on login with GitHub, you'll notice some strange things start to happen. That our website will not work for us. And the reason is that the static generation does not take into account authentication. Because that is a very dynamic part of our application, the pre-rendering is just static HTML. So although it works for these first three, the pre-render is not able to access these other chapters because as soon as it tries to access it, the pre-renderer has no access to the course. It doesn't have a GitHub account. It's not logged in. And so the pre-renderer tries to get to these other lessons, but all that it gets is redirected to that login page. And so that's why when we pre-render this entire application, it only renders these first three lessons. And so that's something that's important to keep in mind is that we don't want to pre-render our entire application, not for what we're doing here. If we had a fully static blog, that would be totally fine. But we don't want to pre-render the entire application. And of course, this does make sense. The rest of this application is dynamic. We never really expected to be able to pre-render it. All we wanted to do was pre-render the landing page. Luckily, Nuxt gives us a way to do that, but not directly. So Nuxt does not have a specific option for this, but we can actually configure Nitro to do pre-rendering on specific routes. To add the configuration for Nitro, all we need to do is use the Nitro keyword here in our Nuxt config. And everything in here will be passed directly to the underlying Nitro server that backs our app. So in this case, we pass the pre-render option and we give it an array of different routes. Now, all of these routes have to be static paths. It does not have support for globs or things like that at the moment, as far as I can tell. But for what we're trying to do here, this works perfectly fine. So once I've added that in, we can run our build command and we'll see that our website builds, but with this one page pre-rendered. So that went by pretty quick. So I'm going to scroll up just so we can see what happened here. So you can see as we get to our pre-render section, like we did before, now all it says is pre-rendering one routes, and it's got just the landing page in here, just as we specified. And then the rest of it is going to be built as part of the Nitro server as it normally would have if we had left this option out. So we see all of the different things in our application. We've got our middleware, we've got different components, we've got all of our endpoints, and all of this stuff is bundled up into different chunks. So now if we run pnpm preview, we can refresh the page. And as we click around, we have access to this first chapter like we would expect. But if we try to log in with GitHub, we're actually able to gain access because we're using the full Nitro app that's backing it. So we have that full dynamic capability. And then if we go to our landing page, it loads extremely fast because it's just a static piece of HTML. No server-side processing is needed to be done. So let's take a quick look at what Nuxt actually outputs for us. So if we open up our output folder, the folder where Nuxt puts all of our built assets, we see we have two folders, public and server. So public is where all of the static files go. So static images, static pages. And you can see if we go into it, we've got our images here. So those are all the screenshots for our landing page. And if we go into our landing page, we've got this index HTML. And if I take a look at what this is, we'll see that at the bottom, we've got a bunch of JavaScript that's inline because remember, we do have JavaScript on our landing page. So it has to include that somehow. So that's what this is. It's inlining that metadata so that we have access to it when the page loads. But if we scroll up, we can just see if we squint hard enough in this minified HTML here that we have our chapter 1, all of these different things are rendered out. If we scroll closer to the top, it might be easier to see that we've got our H1 with the title. And so we can see here that this is the pre-rendered HTML, and this is what loads directly without the need for Nitro to even do anything because it's a static file. But if we go back, we can go into our server folder, and this is the folder for Nitro, for all of the dynamic stuff that Nitro is going to do for us as it runs the server for our application. And so in this folder, we see we've got a chunks folder, node modules, we've got a package.json. This looks more like a node app. And if we go into our chunks, we can see all of the generated chunks that Rollup has provided is stuffed into this folder here. And so all of our error pages, our middleware, everything else that we need for the dynamic portion of our website is in this part of the output. Now we've seen that we can pre-render an entire website with one command, or by specifying a bit of configuration to Nitro, we can pre-render just specific routes on our application while leaving the rest of our application to use universal rendering, like is the default from Nuxt. But we have much more control over that process of rendering if we so desire, and that's by using route rules. And that's what we will cover in the next lesson. In this lesson, we'll take a look at the different route rules that Nuxt 3 gives us. So we've already done the pre-rendering for our application, and so we don't need to do any other interesting stuff with the routes, but it is an important thing that I do want to cover. So we're going to do a little bit of a different lesson here, and I'm just going to explain what's going on with the route rules. So if you go to the documentation, you can see that currently these route rules are experimental. They're still being worked on, but that doesn't mean that you can't use them yet. You just have to be a bit careful about how you do it. So what are route rules? Well, here is an example of the route rules, and we can define per route or per set of routes how Nuxt will render our application. And we can do this with as much granularity as we want. The main things that we can do here are switching between SSR, which we can disable if we want to have a single page app. We can also enable static generation, which is very similar to the pre-rendering that we did before, except it will wait until we have that first request and then generate it. And then it will stick it in a cache. And every subsequent request will use the pre-rendered or the statically rendered page from the cache. So in our application, it actually ends up being basically the same thing. But if you had a website where you had potentially thousands of pages that didn't change very often, so something like, let's say, Wikipedia, you don't necessarily want to spend all of that time up front rendering those thousands of pages at build time if you don't know if they're actually going to be hit. Instead, you can wait until someone actually goes to that page and then generate it on the fly. Along with the static mode, we can also do a stay a while revalidate mode. And this is what enables the full incremental static generation if you are using Netlify or Vercel as your deployment system. So stay a while revalidate, it works very similarly to the static generation, but every time it generates a page, it first serves the cached version to the user, and then in the background, it goes and generates a new version and then puts it in the cache. So we get a balance between fully server-side rendered and fully static. The user will always see the previous version, but if you have people visiting your website, every single hour or every single minute, it will be pretty much up to date. So those are the different rendering modes that we get with route rules, but we also get some other options. And these options are to do redirects. We can optionally modify what kinds of headers are sent with our responses. And then there's a shorthand for enabling CORS if you need that. And what's interesting about these route rules is that they are implemented in Nitro itself, the server. But depending on what platform your app is deployed to, let's say Netlify, Nitro is smart enough to, instead of just waiting for that request to get all the way down to Nitro layer, let's say for a redirect, instead it will deeply integrate with Netlify, and that redirect will actually happen on a lower level so that before that request even makes it to the Nitro server, it already does the redirect, making it much faster. And so all of these things are as deeply integrated with the deployment platform, which does make it more difficult to develop, and hence why it is currently experimental. So now we've covered a bit about how route rules work within Nuxt 3. In the next lesson, we're going to take a look at how we can manage our static assets and optimize them so that they are as efficient as possible. In this lesson, we're going to take a look at the different ways that we can manage static assets in our application. And along the way, we will optimize our images to make sure that they're as fast as possible. In any application, you're going to have lots of static assets. These are any images or logos or icons or really any non-code things that you need in your application. In Nuxt, we have two main ways of dealing with these things. We can put them in our public directory and serve them as fully static assets, or we can put them in our assets directory. Right now, we have all of our images in the public directory. What this means is that Nuxt is serving these images up as just regular files on a file server. So if we wanted to access any of these images, we can just go to that path directly and we can access that image. It's served as separate files on the server. The assets directory, however, is processed by Vite or Webpack if that's what you've configured Nuxt to do. And anything in this assets directory will be processed in the same way that your code is. It will be bundled and loaded up and split off into chunks based on how your application is architected. One main difference is that with assets, we can put in plugins. So plugins for Vite to load icons or to compress them or to optimize them in some way. And that's actually really useful, which we will do at the end of this lesson. So how do you know whether or not to put something in this public directory or to put it into this assets directory and have it included in the bundle with your code. Well, if we back up a second and think about what is going on, it will help us to determine where files should go. So with the public directory, these files just sit there. And as we update our code and the application is built every single time and redeployed, these files don't change. However, in the assets directory, every time we rebuild our application, these assets are going to get reprocessed every single time. This means that in the public directory, we want to put things that just don't change that often. So things like your robots.txt file or a favicon or something like that, things that generally you aren't going to update or change over time. In the assets directory, however, we want to include things that do change over time. So things like our CSS styles. Maybe we put fonts in there and images. Now, fonts and images don't always change a lot, but what assets directory lets us do is to process those things. And we want our fonts to be optimized and as efficient as possible, which the public directory does not let us do. One last thing to keep in mind is that because these files are being processed and pulled into the bundle of our application, the file names are going to change. So because everything in the public directory is essentially untouched, then anything that needs to have a very specific file name, for example, the robots.txt file, we leave those things in the public directory. And things like images or style sheets, it doesn't matter what the names of those files are, as long as our application can load them. And so that's perfectly fine to put in the assets directory. In our application right now, we have all of the images inside of the public folder, but it would be better to put them in the assets folder where we can then apply a compression plugin and have it all bundled up nicely. There's no reason for these to be in the public folder. So we'll just change the name to assets and then open up our landing page. Right now, we are treating all of the file paths as regular strings in our source code. Down here, we have our screenshots array listed out. And this works fine because the screenshots are only loaded in the browser. And so when the browser encounters this URL in the image tag, it can find that image based on the path here. But with assets, we actually need to write the code in such a way that the bundler, Vite, can find that image and load it in, and it knows that it should load it in. And so if we have just a URL like this, Vite doesn't know that this is an image that it should be including somewhere. So instead, we need to import all of these images, just like we would import some code. And we have to import it from the assets directory. And once we've imported these files, we can then update our screenshots array to just use the variables here that we've imported. And what Vite will do is when it sees that these are images that are getting imported, it will actually resolve these variable names to those paths. So then when we use them in our code, it will pull in the appropriate image. So now we need to just restart our dev server here. And now if we inspect this image up here at the top, we'll see that this image no longer refers to /images/screen3.png. It's at this _next/assets/images. This is from the bundler. It's the dev time bundler, but this is where Nuxt is putting all of the bundled assets. If we run pnpm build, it will now build it, but with the assets included in the bundle. So if we go to our output, we'll go into public, which is where it bundles them, but then puts them into the public server so that the images can be accessed. If we go into our landing page, we see that we have that HTML from before, from the previous lessons where we pre-rendered that landing page. But if we go back into this Nuxt folder, then we can see that it's generated all of these different files. So this is all of the JavaScript and the CSS for all of the different pages that we have, including a chunk for composables, a chunk for the course progress, Pina store. But if you notice over here, we also have the images, but they have these hashes on them. And Vite does this so that we can identify each image uniquely. So this hash is based on the content of the image itself. So if the image ever changes, the hash will also change. And so when the browser is loading that image, it knows to load a new image. But if the file has not changed at all, this hash will stay the same. And the browser knows it can just rely on what's already in the cache instead of loading up that image again. So that's another benefit of using the assets folder over the public folder for things that change often, is that it makes it easier to bust the cache on your browsers. So now we're going to compress our images. If we look at what this image is here, we can see that it is 779 kilobytes, but that it's a pretty big size here. It's only rendered at 900 by 558, yet we have this image that's quite large. So one thing that we can do is specify a smaller image size, and we would do this with responsive images, which we won't get into in this course, but you can find lots of great information online on how to do that. The Nuxt image component, which is currently in beta, is also a really great tool for doing this, but right now it's too experimental to really use all that well. But one thing we can do is optimize it using an optimization plugin for Vite. So we'll install the Vite plugin V#, and then we'll come over to our Nuxt config in order to get it to work. So we have to import V#, and then we need to add in a Vite configuration section. Now we'll run our build again, and we'll see that Vite compresses these images. So if we scroll up here, we can see that in our output here, V# is compressing our images, and it actually compresses them quite a bit, about 70-80% on average, which is quite a big difference. If we look at the dev instance that we've got running here, if we look at our network, I'm going to clear this here and refresh. Get this dev instance running again. If I refresh this, we'll load all the things on the page, including all of these images here. If I just filter down to image, at the bottom here, it shows that we're loading 2.5 megabytes of images. That's half of the page. If we reduce that by 80%, that's a pretty big savings in terms of bandwidth that we're using. And by saving on bandwidth, we're making our page load a lot faster. So adding in optimization plugins like this is really beneficial. In the next lesson, we will begin working on integrating Stripe with this checkout page so that we can actually get paid and then allow those paying customers access to our course. In this lesson, we'll learn all about lazy loading components. So one other optimization that we can make to our landing page in order to allow it to load faster is to simply not load as much code initially. So with our buy now button that we have here that loads that payment modal here, well, most people will not even check out. Most people won't even click this. And if they do, they're only going to click it after they've been on the page for 10 or 20 seconds at the least, maybe even 5 minutes or 10 minutes. So we don't need to load all of this code here for this component on that initial page load. We can load it later on. So if we open up DevTools, we can actually see this component being loaded. If we clear this out, we'll refresh the page. And here we can see all of the different images. We can also see our payment component here. And it's loaded on that initial page load. You'll also see further down that we've got the modal component loaded. And that's because our payment component in turn uses that modal component. So it's loading both of these components on that initial page load, which we don't need it to do. Lazy loading components is actually really easy in Nuxt 3 because all we need to do is add lazy in front of that component name. And instead, Nuxt will now only load that component when we actually need it. And that's controlled by this vIf here. So when it's false, that component doesn't need to be rendered, so we don't load the code. But if it's set to true, that triggers that loading, and the component is then fetched and rendered into the page. So if we go back to our landing page here and I refresh, we'll see that we don't have that payment component anymore. But as soon as I click on this button here, that payment component is loaded and rendered. In our case, this payment component is currently only quite small. I don't know what the full size is as it is cached. 145 bytes seems a little too small. Why don't I force refresh this? Try it again. There we go, 6 kilobytes. So if we only load it later, we actually save at least 6 kilobytes because the modal component itself is being loaded as well. So if we search for that, and I'll refresh the page again, we'll see that we actually only load the modal as well once that button is clicked because of that cascade. The modal is not loaded until the payment component is loaded because the only place that this modal component is used is inside of this payment component. So of course, as these components get bigger and bigger and bigger, the total weight savings and improvement of your performance is going to go up. And so this is one really simple way to improve the performance of your application if you have a bunch of features that don't need to be loaded on that initial page load. In the next lesson, we're going to take a look at runtime config and app config, two different ways that we can provide variables to configure our application. In this lesson, we're going to take a look at the differences between runtime config and app config. Nuxt gives us these two different ways of providing configuration variables and environment variables to our applications. And there are some subtle differences here, which can get a little confusing. So I wanted to take a moment to explore the differences here. Runtime config is generally things that are specified at runtime. So after your application has already been built and you are running it, there are different things that might change. And so try and keep that in mind, is that runtime is for run time. And we'll see what this means more in just a second. So we define it in our nuxt config file with the runtime config key. It doesn't require its own special file. While your application is running, the values in the runtime config are reactive. The main difference here between runtime config and app config is that runtime config values are specified after your component has been built. So these are things that you don't know at build time. Things like the URL for your database or various different secrets. These things change depending on the environment that you're running it in. If you're running it in a staging environment or in production environment, those values are going to be different. Yet, you'll use the same built application. So you build it once and move it around between different environments. And so every time you move it, you need to give it new values. And so that's what the runtime config is mostly responsible for. So generally, any environment variables, secrets, and tokens that you're going to include in your application would go inside of your runtime config. In our case, we're using it for Supabase keys and Prisma keys. Well, actually, we're not using it a lot yet, but the Supabase module does that for us under the hood. When we provide those Supabase keys, the Supabase Nuxt module actually sets runtime config for us under the hood. If you inspect the GitHub repo, you'll see that it's doing this. But because it's a module, that's abstracted away from us and we don't need to worry about that. And in the next lesson, we'll see how to use runtime config with our Stripe keys. App config is broadly everything else that we want to use to configure our application. So this requires a special file, app.config.ts. It is also reactive. Because Nuxt 3 is Vue, we're going to make everything reactive just to keep things straightforward. And of course, why not? Because reactive values make things so much better when we're developing. The difference here is that these values are all specified at build time. Although they are reactive and can change as our application runs and different things happen, all of the values are defined at build time. We can't use environment variables to change them. If you want to do that, then you can use runtime config. So generally, we'll put less sensitive things in here, such as the theme that we're going to use, some sort of other configuration like that. And what's interesting here is because it's reactive, we can actually change these things per request. We also have full TypeScript support because it's defined at build time. Runtime config, because we're taking in environment variables and other things like that, we can't really use TypeScript to enforce types in quite the same way. So for example, if we wanted to implement dark mode and light mode on our application, we could use app config to toggle that on and off. With each request, we could set the config, the theme of our application to dark mode, render out the entire page that we want to serve back. And then in the next request, we could switch that theme to something entirely different. So that is a quick overview of the differences between runtime config and app config. In the next lesson, we'll begin to set up Stripe so that we can finally accept payments and get paid. In this lesson, we're going to create our Stripe account and then set it up using environment variables and the runtime config that we just learned about. So the first step is to create our Stripe account. It's pretty straightforward to do. And once you get to this activate payments on your account screen, feel free to skip for now. This will give you a dev account, which you can't actually earn money with yet, but you can always activate payments later on if you actually do want to go ahead and charge people for whatever you're selling. Before you have your payments activated, Stripe will automatically put you into this test mode. So up at the top here, you can see that we've got this toggle switch. And what that means is that we're now switched into test data mode. So this makes it really easy to use the Stripe dashboard and all of the different APIs in test mode and see it working before we switch to live data and start to actually charge credit cards and do all of that payment processing. So now we need to set up our application in order to use these environment variables that we'll get from Stripe in just a moment. And to do this, we'll set up our runtime config. So we'll go over to our Nuxt config file and add in a runtime config section. The runtime config comes with two main values. We have public and server values. So by default, any values you put in are going to be only visible to the server and they're not going to be sent over to the client. But by putting them in the public object, we can make them available to our client. In order to set up Stripe, we have two different keys here, which when we start up, our account are displayed nicely for us right at the beginning of the dashboard here. We've got this publishable key, which is the public available one. And then we've got the secret key, which we only want available on the server. So to set that up, we can put Stripe secret in here. And then we'll add the public value. One thing that's really convenient is how easy Nuxt makes it to override these runtime config values using environment variables. All we need to do is prefix our environment variables with Nuxt underscore and then the name of the key. And if it's a public key, we need to make sure that we include this public in the name of the value here. So let's open up our .env file. And I'm going to put them side by side here so we can see how these names map to our runtime config. For the Stripe secret, all we need to do is type Nuxt underscore Stripe secret. And for the public key is similar, but keep in mind we need to have that public keyword in there as well. So now that we have it in our .env file, Nuxt will automatically pull that in when it's building. In order to use these values, we have the use runtime config composable. So I'll just demo these out for us just to see what's going on here. I'll start our dev server here and switch over to our landing page. So if we come over to our dev server output here, we see that it writes out secret public, which is exactly what we would have expected because we're logging out first our Stripe secret and then the public key. But if we come over to our browser DevTools, we see that the Stripe secret is undefined. And this is because that secret is not sent over to the client. Only the things inside of this public object are sent over. But we're not going to use these values on this landing page here. So let me get rid of this code and let's copy in the actual values into our .env file. We'll go back to our Stripe dashboard here and we'll copy in the publishable key to the public value here. And then the secret key, we'll click to reveal and copy. Now we've got our keys set up in the way that we need to do them. It looks like I have some extra Stripe keys here from previous development, and we don't need those. So I'm just going to delete those because that's a little bit confusing. And so there we go. We've cleaned up our .env file, and now we're ready to start integrating Stripe into our application. In this lesson, we're going to update our checkout component so that we can integrate it with Stripe and accept payments. So right now we have in our landing page this buy now button, and it opens up this checkout component here. Now, this doesn't really do anything yet. We just have this input here for an email and this button that doesn't do anything. And so that's what we're going to change in this lesson. We're going to hook this all up to Stripe. So the first thing that we're going to do is we're going to load up an external script from Stripe. We'll do that using the useHead composable. This script here will load a Stripe object, which will let us create a card element, which will make it really easy to input credit card information without us having to write all of that complex logic ourselves. It also comes with the necessary methods to interact with the Stripe API. So what we've done here is we've set the source, but we've also set this on load parameter so that once this script is loaded, then we'll call this setup Stripe method. Before we create the setup Stripe method, we're first going to create a few values for ourselves. We're going to grab the config from our use runtime config, like we saw in the previous lesson. Then we'll create a ref for the Stripe object, and then a ref for the card itself. We'll add in this setup Stripe method along with an object to describe the styling for the form that we want. And we'll also create a computed value here, which makes it a little bit easier to grab the elements from our Stripe object. In the setup Stripe method here, we're going to use this Stripe object, which we've got from that external script that we just loaded, and we'll grab the Stripe key from our runtime config, and this will create an object that we can use to interact with Stripe. Then this next section here, we create that card element and then mount it to the DOM. We'll mount it to this element that has the ID card element. We don't actually have that yet, so we're going to add that in right now. So what this does is that as soon as the page is loaded, the Stripe object is created and it will create and attach that credit card input element to our form right in here. And that will do credit card validation for us. And then we can use that info to then make the appropriate API calls to Stripe. So if we now open up our checkout process here, and actually we need to move this useHead call down after our setup Stripe method. I'm not entirely sure why that's the case, but otherwise it gives us an error. So it seems to work this way. So now if we open up this checkout process here, you'll see that we have this card element as well as the expiration date and the CVC code. And it automatically takes care of formatting and validation and all of that stuff, which we don't have to do it all because Stripe provides that for us. The next step is to hook up a method that will handle the submit of this form and actually make all of these calls that we need. So for that, we've got a few more refs that we need to create. We'll have an email ref to keep track of the email that we're typing in here. Then we'll have two different values here that keep track of the state of our application. So we'll use processing payment to basically show a loading indicator and make sure that we're not going to accidentally submit that payment multiple times. And then we'll have a success variable here, and we'll use that to be able to flip between this checkout screen And then once the payment goes through successfully, we can show a thank you page basically inside of this modal here. We've got our submit handler here, and it is a bit long, but it's fairly straightforward. First, we check to see if we have an email input. If we don't, then we can't charge to the user, and so we return early. Then here we put processing payment to true to indicate that we're in the middle of processing. At the very end, here we do a finally and set it to false so that even if there's an error, we are going to reset that back. This first API call is going to be to our own API. We'll implement this payment intent endpoint, and that will create this payment intent object, which we need. Once we've gotten this object back, then we can use that object to call Stripe's API, confirm card payment. We grab that secret, pass it to this payment along with the card, and then Stripe can take that card data and that payment intent data and use it to charge the credit card. And then if that comes through successfully, we set success is equal to true. So that's the rough overview of what we're going to do here in this method. So the way that Stripe works to charge credit cards is that we can't make a call from the client side straight to Stripe because that's not secure. If someone is motivated enough, they could dig into the code that is on their browser and change whatever value they want to 0 or to $1. And they could basically get away with buying whatever they want for essentially free. But if we had the entire thing go through our own server endpoint, then that means that we would have to keep track of all of that credit card data. And the problem with that is that there's a bunch of regulation and security concerns around handling credit card data, and it becomes very complicated because of that. And the way that these payment processors work is that to get around this, what we do is instead we create this payment intent. This payment intent does not have any of the customer's data in it, except for this email here, but it doesn't have any credit card or financial information in it. This payment intent instead says to Stripe, we're going to charge $97 to this person. Here is that object. And then Stripe returns with this secret. Then when we pass the secret along with the user's data straight back to Stripe, so this credit card data does not go through our own servers, then it can use this secret to confirm the amount that we want to charge this user, as well as the product that we're charging them for and any other information that we've provided in this initial call. So instead of dealing with either the client side or the server side route, it will actually do both. The security of defining the amount that's being charged via our own server endpoint, but the security of not having that user's credit card data pass through our endpoint by passing it straight from their browser to the Stripe endpoint. Now that we've set up our front end for the checkout process, in the next lesson, we'll set up that payment intent endpoint so that we can generate this object for our checkout process. In this lesson, we're going to add the payment intent endpoint and update the checkout process and add some UI polish. So in the previous lesson, we added this handle submit handler here, and it calls this payment intent endpoint. So we're going to implement that now. But first, we're going to put this handle submit onto our form because we haven't done that yet. So we'll do a submit.prevent so that we don't actually do a full form submission because that will refresh the page and that's not what we want at all. So before we add in our endpoint, we'll need to add Stripe as a dependency to our project. And with that out of the way, we can add in our endpoint. So we'll come over to our server/API folder here, and we'll add in a Stripe folder. And before we actually create the endpoint, we're actually going to create a stripe.ts file. Since we'll need this Stripe object configured and set up for this endpoint, as well as the endpoint we'll create in the next lesson, we'll create a file that they can both import from instead of reusing that, or instead of recreating that code twice. So the code here is pretty straightforward. We're going to import this Stripe here. And then just like we did in our payment component, we're going to grab the secret from the runtime config, but this time it's not the public key, it's the secret, which is only accessible on the server. And then we'll use that to create our Stripe object here, which will then export. Then we can create our endpoint. And all that we're doing in this endpoint here is we're going to grab the email from the request and add that as the metadata to our payment intent. And we're going to set the amount, which is in cents, in the US dollar. So this payment intent represents not a successful transaction, but just the intent to make a payment. Sometimes these payment intents can fail, or if someone tries to pay and they don't have enough money on their credit card or in their account, it'll come back as failed. And so we can see that this is not the actual final charge, but instead, as I had mentioned in the previous lesson, this payment intent is used to then sync up with the user's credit card data so that Stripe can confirm that we actually want to charge this amount with this metadata. If you have multiple different products, you probably wouldn't want to hard code the amount in here. You'd probably want to create a table or multiple tables to represent the different products and their different prices and packages and whatever else you have going on there. And you can include that data in the metadata field here, which products are being purchased and any other sort of information, so that when that payment goes through, you can confirm which product you want to give access to. So when we get this payment intent object back, all that we want is this client secret off of it so that we can pass that back to Stripe's API to confirm the payment. So once this comes back, we get it here in the response, and then we take this secret here and use it to confirm the card payment, which will then go through and charge the credit card. So now we should have everything hooked up properly in order to actually make payments using this form. So if we go to our Stripe dashboard here, you can see that there are already $253 worth of charges, and that's just from some testing I was doing before I hit record on this video. And if we go to payments, we'll see that we've got 2 successful payments as well as 1 incomplete. If I make sure to refresh the page just to ensure that everything's all there, I'll enter in my email. I'll put Mastering Next 3. And then for the card number, we're going to just repeat 42 over and over again. This is the test account number. And once you've spammed that in there, you can hit pay. And we'll see nothing on our end here because our UI does not have any stuff hooked up yet to respond to this success ref here. But if we go to our payments endpoint, we'll see that this new value came through. And if we click into this value, you'll see Michael plus MN3 and michaelntson.com. You'll see the payment method, the credit card ending in 4242. And you'll see that we've got the amount in here, 97 USD. Because I'm in Canada, it will automatically convert it to Canadian for me, as well as a bunch of other data here. And it will also include this metadata here in this metadata field. If we go back to our dashboard, we can see that this payment has gone through. Now this value is 380. Again, this value here is in Canadian dollars for me because I'm in Canada, even though we charged in US dollars. So now that we're actually able to accept payments, we need to improve this user experience a little bit for us. So first we're going to update our button here to have a loading state. So we'll replace this with this here. And we'll use this loading component here that I've added previously to add a loading spinner. And we have this dynamic class added here, which will check to see if we're in a disabled state or not. And so we'll add different styling if we are in a disabled state or an active state. We also want to add a success state to our checkout. We'll go up to the top here and add that in over here. If we've succeeded in our payment, we're going to say, thanks for buying the course. And then we're going to provide a link to log in with GitHub. And this is what we're going to implement in the next lesson. But before we get there, let's just check out what these changes are to our UX. So if I hit my email address, I'll pop in my fake credit card here. Then I'll hit pay and it has that loading spinner. And there we go. It went through successfully. We'll double check. Now we're at $500. So, we're earning quite a bit of money today here. And all that's left is actually granting access to all of these people who are buying our course. So that's what we'll cover in the next lesson. In this lesson, we're going to go over the architecture for how we will be granting access to our course. It's a little bit complicated, so I wanted to go over this in some more detail. So we have two main problems that we need to sort out using this architecture. The first one is that relying on our front end in order to grant access to our course is not that secure. So we can't just rely on the response from that Stripe confirm payment method, because if we grant access from the front end like that, that means that anyone who wants to exploit our system can just access that from the front end. And so it means that our course platform here would not be as secure. So we want to handle all of that entirely on the back end. And we can do that using Stripe's webhooks. The second thing that we need to do is to link the purchase with a specific GitHub account. Our entire auth system is based on GitHub, and so we need a way to associate that GitHub account with the Stripe purchase. Our first step is to create a course purchase object. So our user purchases the course, and then in that payment intent endpoint, we are also going to create this course purchase object in our database. And it has three really important fields that we need to remember. The first is that we're going to set this verified flag to false, because we're going to wait for that Stripe webhook in order to confirm that this purchase has actually succeeded. The second thing is we are going to set the email by default to the purchase email. In the third step, we will update this field to make sure that it is the same as the GitHub account. But in many cases, the purchase email will be the same as the GitHub account email. So we might as well just set it to that to begin with. The third thing is we're going to add in the payment intent ID here. And this will let us keep track of which course purchase object we need to be updating throughout this whole process. It's the ID that'll let us track through the flow. So once this course purchase object has been created in our payment intent endpoint, we return and then we confirm that payment with the Stripe endpoint. And at some point, the Stripe webhook will fire back to our endpoint. And we can use that to then set this course purchase object to verified equals true. One thing to keep in mind is that we don't have any control over when this Stripe webhook will fire. So we need to make sure that nothing relies on this step and that we don't accidentally introduce any race conditions here. So that's why we have to create this course purchase object when we create that payment intent in order to prevent any sort of race condition, because we want to make sure that this course purchase object exists when this Stripe webhook fires. The third step in this process is to link a GitHub account. So after this payment has gone through successfully, and while the Stripe webhook is firing at some point, we will get the user to log in with their GitHub account. And once we've done that, we can grab that email from that user token and then use that to update this course purchase object. So at this point, we have made sure to verify using the Stripe webhook and updated the email so that the course purchase object is now linked with the GitHub account. So we've solved our two problems. The final step in this whole process is how we actually check for access when the user is logging in. When a user logs in to our app using GitHub, in our middleware, instead of just checking to see if someone has logged in or not, we can now check for that course purchase object. But we're not looking for just any object. We are looking specifically for an object where verified is true, so we know that the course has actually been purchased and the payment didn't fail for some reason, and where the email matches the GitHub email. So this will find any course purchase object that's associated with the user and associated with a successful purchase. If we find that object, we know that the user has access to the course. And if we don't, then they do not have access. Now that we've gone over the process for how we will grant access and then check for access in the course, now we need to implement that over the next few lessons. In this lesson, we'll be tackling the first step in granting access to the course, and that is to create the course purchase object. To do that, we'll first add that model into our schema here in the Prisma schema file. So I'll copy in this course purchase schema here, and when I save the Prisma extension, we'll update the relation to the course here, as we would expect. There we go, course purchase. So what is in this schema? So we've got our regular ID here. We've got created at and updated at, which are some pretty default fields here. Then we're also going to link a course purchase to a specific course so that we know which course was actually bought. We're going to have that user email so we can link with our GitHub account, a verified flag, which we will default to false. And then we're also going to have this payment ID string so we can keep track of which Stripe purchase this course purchase object refers to. And we're going to add this unique attribute onto it because for every payment ID, there should only be one course purchase object. So now that we have updated our schema, we'll just run a Prisma migrate dev in order to add that migration to our Supabase database. And it looks like as I was preparing for this lesson, something weird happened with my database, but thankfully Prisma detected this drift for us. And so all that we need to do is hit yes, and it will reset everything and make it all pretty again. Okay, so now we need to add in name for the migration, which is add course purchase model. And now our database is all set up and ready to go. In order to create the course purchase object, we are going to add that into our payment intent endpoint. The reason that we are going to put that in here is that, first of all, we'll have access to the payment intent here, so we can easily grab that ID and then link it. But at the same time, we need to make sure that this course purchase object is created before the Stripe webhook has a chance to fire. Because if the Stripe webhook fires before our course purchase object exists, well, it won't be able to find it, and so it cannot verify it. I've added in a few different changes here. The first of which is importing Prisma so that we can update our database. And after we create that payment intent object, we then come down here and we create our course purchase object. We're going to default to the email that was passed in with the Stripe purchase. We're going to hard code the course ID to 1 because we only have a single course for now. And then we'll also add in that payment intent ID. I also added in a bit of error handling because I noticed that it was missing. And so I might as well put some try catch blocks and throw some errors just so we have a bit more error handling going on here. And so with that, we have all that we need in order to get this first piece of the puzzle sorted. We have our course purchase object being created as we create that payment intent, and it's all linked up and ready to go. In the next lesson, we'll see how we can use Stripe's webhooks to verify this course purchase. In this lesson, we're going to tackle step 2 of granting access to the course, which is listening to the Stripe webhook so we can verify our course purchase. Webhooks are a pretty common feature of APIs, and Stripe has their own webhook implementation. It lets us register an API endpoint that we host, and then when different events happen with Stripe, Stripe can then ping our own API with those events so that we can get notified of different things happening in real time. So for us, this means we can listen for when a payment intent is created, when one succeeds, when one fails, and a whole host of other different events that can happen in the Stripe API. We'll create our Stripe webhook handler in the Stripe folder here. We'll create a new file. We'll call it webhook.post.ts, since we'll only be listening for post events. And we'll paste in this code here, and I'll take a moment to explain what's going on. So our event handler here is set up so that we can handle any sort of events from our webhook, and then we'll create individual methods to handle the individual events. And this makes it really easy to add any new events in the future as we need them. We'll first grab the Stripe webhook secret from our config, and we'll get this webhook secret in just a moment. But in the event handler, the first thing that we do is grab the signature from the headers. Stripe sends this along so that we can verify that the webhook event was sent by Stripe themselves and not by someone trying to impersonate Stripe. So this first block of code here, we take that webhook secret, we take our signature, and when we pass in the body, we can use this construct event method that Stripe gives us, and it will take the signature and verify that this event indeed came from Stripe. And once we've got our Stripe event, we can then take it and process it down here. And so all we're going to do is have an if-else statement here where we can check to see what type it is, and then based on that type, we'll call a method to handle that. One thing to note is that here we have to use read raw body instead of read body, because we want to avoid any of the processing that H3 will do for us because it modifies the body in a way that prevents Stripe from being able to verify the event correctly. So once we've got our event verified and we know that it's a payment intent succeeded event, then we're going to handle that event here. So we just need to create that method. And this method is pretty straightforward. We're going to take in a payment intent, and then we will update that course purchase object where the payment intent matches the payment ID here. And we just flip this verified flag to true. Then we wrap it in a try catch to do some error handling. And that's basically it. It's pretty straightforward. One thing I added is this payment intent type. And all that I did was add in sort of a dummy type in a way. I'm not sure if it has an official name or anything, but that's what I would call it. And so one interesting thing about TypeScript is that it is not going to get rid of fields in your object. All TypeScript does is ensure that the object that you are typing has, at minimum, the types that you specify in there. So when I set a type of payment intent and it only has an ID, that means that when we come down here, we're able to use the ID here because it knows that this object for sure has a property ID. Of course, the object that we get back from Stripe has many more fields than just ID, but TypeScript doesn't really care about that so much. It's only looking to see if the object has at least the fields that you said it did. Now, of course, not every single payment intent will succeed. Sometimes we enter in our credit card information incorrectly, or we realize that our bank account didn't have quite as much money as we thought it did, and the payment fails. Because we're creating a course purchase object for every single payment intent that gets created, if we try to buy the course 5 times in a row and it fails every single time, we'll clutter up our database with those 5 objects, and they're never going to be useful because they're never going to be verified. This might not be a problem, especially for a small course platform like we have. There's not going to be a lot of data piling up, so there's not necessarily a huge performance consideration in terms of cleaning it up. But although there's not a huge performance consideration, it kind of makes me feel a little uneasy to know that there's all this useless data piling up. And so I want to clean that up. So what we can do is when a payment intent fails, we'll just delete that whole course purchase object from the database since we no longer need it. So I'll add in an else if here using the payment failed event. And then we'll do a similar thing here. Handle payment intent failed, pass in the Stripe event data. We'll close that tag. And then we just need to add that method in. And this method looks very similar to the one we just added. We're going to take in a payment intent and use that to find this course purchase object. But we will then delete that course purchase object. Now let's test our webhook to make sure that it's actually working the way we expect it to. To do that, we will first install the Stripe CLI. The Stripe CLI lets you do a whole bunch of different things, including simulating webhook events or forwarding webhook events to your local dev instance. Because remember, it's trying to ping an API. And so usually that's pretty hard to do to get a hosted API to hit our local running instance. And so the CLI lets us forward those events to our locally running API. It also helps with all sorts of other development things when dealing with Stripe. And so there's a lot of different ways that you can install depending on your environment. And the documentation here is very good and very detailed. So I would suggest you go through that to install the CLI. I already have it installed on my machine here. And so the first thing that you want to do is run Stripe login. And what this will do is give you a URL that you can open in your browser, and it will link your CLI with your Stripe account. I've already done this, so I'm just going to cancel that for now. The next thing that we want to do is get our server running. So I'll hit pnpm dev. And in a second terminal, leaving our Nuxt instance running, I'm going to run stripe listen /, and then I'm going to grab the URL of our Nuxt instance. So we're running here at localhost 3000, which is exactly what we want. So I'm going to paste that in here. And then we're going to add in the endpoint for our webhook. So API/Stripe/webhook. And once we do that, now Stripe will be forwarding any webhook events to our local instance. Now we also need to grab this secret here and open up our .env. And in here, we'll create an environment variable called Nuxt Stripe webhook secret. And you're just going to paste that in there. We also need to make sure to add a default value into our Nuxt config so that Nuxt will overwrite the config value with this value from the environment variable. And so we had our environment variable set to Nuxt Stripe webhook secret. So we will create one here called Stripe webhook secret. And now everything is set up and running and ready to go. So we've got our Nuxt instance running the webhook API endpoint. We have Stripe listening to webhook events and then forwarding them to our Nuxt instance. The next thing we need to do is to generate some webhook events. So if we run Stripe trigger, we can do payment intent dot succeeded, and this will generate a dummy payment intent succeeded event and send it to our webhook endpoint. So the trigger went through. Now let's check to see what happened. If we come here, we can see that in order to do a payment intent succeeded, it needed to send charge succeeded, and it also created a created event. You'll notice that we have this 500 error here. So it hit our endpoint, but returned a 500 error. So let's see what's going on here. Well, it looks like we didn't log anything out here. So let me put in some logging here so that we can see what's going on. All right, so I'll trigger this again. And we'll see that 500 error come through again. And if we look at this, we can see the record to update is not found. Well, that makes sense because this dummy event does not have the payment ID. And further, we haven't even created any course purchase objects yet. So of course, there's nothing for it to find. But at least we can see that Stripe is indeed hitting our endpoint correctly. And this payment intent succeeded is in fact running for that event as we would have expected. Similarly, if we trigger a different event, we'll do the payment intent failed. If we go back here, we can see record to delete does not exist. So there we verified that our webhook is working correctly. We just need to pass it in the correct data. So we'll close this terminal that we were triggering events from, but we'll leave this to forward events to our webhook so that we can test it with the whole checkout process. So we'll go back to our landing page here. We'll hit buy now and we'll enter in a test account, MN3 for Mastering Next 3. We'll put in some credit card data and we'll hit pay. So now we have a successful purchase that went through. Now let's open up Supabase and check the database there. Open up the course purchase here. We can see that we created one, and this was just created now during our checkout process. The user email is Michael plus MN3, exactly like we added. And it looks like verified is already true because the Stripe webhook fired. If we go to our Stripe dashboard, we can see that this event just came through here. But we can actually go over to our developers tab and see exactly what's going on. If we go to the events page here, we can see these are some test events generated from the CLI. It defaults to $20 USD charge. But then these ones for $97 are from our checkout process. And if we go over to the webhooks pane here, we can see that it shows our local listener right now. We've got pointing right to our local instance here. So an important thing to note is that when you deploy this, you will want to add your endpoint over here into hosted endpoints and make sure that you're pointing the Stripe webhook at the correct URL. At this point, we now have steps 1 and 2 running successfully. We create our course purchase object, and then we listen to the Stripe webhook in order to verify that purchase. In the next lesson, we'll tackle step 3, which is linking GitHub to this course purchase object. In this lesson, we will work on step 3 of granting access to our course, and that is linking the course purchase with a GitHub account. In order to link a GitHub account with this course purchase, we need to redirect the user to the login page right after they've bought the course. So far, we have some support for that. And by some, I mean we have a single button here that does nothing. So if I do a quick test here and I'll pop in this credit card, we can see that our purchase goes through successfully and we're presented with this button here. Now we know how to redirect to the login page and get them to log in, but what we want to do is not just have them log in, but once they've logged in, we need to redirect to yet a different page, and then that final page will grab their email address and then link it with the course purchase. So we need to grab the payment intent ID that we created through this checkout process and pass that along to the login page and then to this final page, which will use that payment intent ID to sync the two things up. So we'll go into our payment component here. And the first thing we'll do is add in a ref to keep track of that payment intent ID. Then we'll need to make sure to set that payment intent ID. And we'll do that here where we get a response that's successful. So we'll set payment intent ID.value. So now we have access to this payment intent ID. The next step for us is to implement a login method. This method will first check to make sure that we actually have this set because it's necessary, and then we'll set up a redirect URL. And so the final page that we want to redirect to after we've logged in is going to be this link with purchase endpoint. And we'll also pass along this ID so that we have access to it. So this is exactly how we've done the redirecting in the past. And so we can just leverage this redirect logic that we've already built in. Going back to our button up here in the template, we can see that we've already added this event handler for the login method, even though that method has not existed until just now. So we do not need to do anything more on this page here. But what we do need to do is implement this endpoint. So in our server directory, we'll go through to API, and then we'll stick it in the user folder. Because it's an action on the user object, we're going to link a GitHub user with the purchase. So we're going to create a new file. We'll call it link with purchase / payment ID. And that will create a folder and then the event handler file for us. Now we've got our event handler for the link with purchase endpoint. We're going to grab the payment ID from the route. We're going to grab the user that's logged in. And then based on that payment ID, we're going to grab that course purchase object and update the email. So this is everything that we need to do in step 3 to link the GitHub account with the course purchase. However, we're not able to redirect straight from the OAuth process back to this endpoint. We have to redirect to a page and then wait for that page to have that session available. If we redirect straight here, there is no user in the context. And so we have no way of accessing that logged in user. I'm not 100% sure why this is the case, but based on my testing, this is what happens. So we first have to create this sort of a dummy page that we'll use to just make this call. So in our pages, we'll add the same endpoint naming structure or the same route. We'll call it link with purchase / payment ID. And this page is going to be very straightforward. So all we're doing in this page is we're going to grab the user, but since that user isn't available immediately, we have to wait. So we throw all of this logic inside of this watch effect. And as soon as the user becomes available, as soon as that logged in session becomes available to us, we will make this API call to that endpoint that we just created, making sure to pass along those request headers so that we can keep that session, just like we did with the use fetch with cache composable that we created earlier on in the course. And then as soon as that has happened, as soon as we finish with that request, we are going to navigate back to our home page. We're going to use this replace so that the navigation happens as though it never happened. So that when you hit the back button, instead of returning back to this page, you'll go back to the landing page. So we're going to try and make this as seamless as possible. We're going to have a very quick UX here. So if I make sure to save that, then I can come in here and we'll test this out. I'll put this and I'll say test checkout flow. That way we can find it in the database more easily. So I'll hit pay. That should kick off the flow. So we'll go check in the database to see that it has been added. So here we go, test checkout flow. So we've added that course purchase object to the database. And the Stripe webhook has already come in and triggered. So it's very fast. We can't actually get it where it's still false because most of the time it's pretty quick. So I'm going to come back here and now I'm going to hit login. We're taken back to our login page, but here our redirect to is set with link with purchase / the payment intent ID. So I'll hit login with GitHub. It'll do the redirect. It'll make the API call. It happened very quickly. But if we go back to our database now, I'm going to refresh this. You'll see that this third row here, the email address is no longer test checkout flow. So now we have successfully linked our GitHub account with this course purchase object. In the next lesson, we will tackle the final piece of this puzzle, and that is updating our middleware to check for this course purchase object. In this lesson, we will complete step 4 of granting access to the course, and that is to check in the middleware for that course purchase object. The first thing that we're going to do is implement a has access endpoint that does this check for us. And we'll do this for 2 reasons. One is that in the route middleware, we do not have access to Prisma because the route middleware will be run in the client and Prisma can only be run on the server. The second reason is that we need to access it from both the route middleware as well as the server middleware. So making a single endpoint simplifies that for us. So we'll come in here and we'll add this into the user folder. We'll call this hasaccess.get. And this endpoint is pretty straightforward. So like we did with the payment intent for the webhook, I've introduced just this simple partial type or dummy type, whatever you want to call it. So that TypeScript knows that this user object has an email on it. That way we can tell TypeScript that the user in the context is of the user type and grab its email from over here. So our logic first checks to see if a user exists at all. And if no one's logged in, well, then this user has no access. But if there is a user logged in, then we're going to check our database for a course purchase object. So we're going to use the find many method because there's no unique modifier that we can access. So we have to look for many of these objects at once. But really that doesn't matter for us because all that we care about is if there are 0 or more than 0. And so the conditions that we're looking for are that they match the user's GitHub account email, that it is verified, and that it matches this course ID. In theory, you could leave this course ID check out because right now we only have one course, but in the future, you'd want to make sure that you update this appropriately. So we check our database for these course purchase objects, and then all we do is return a check to see what the length of that is. If it's 0, we return false. If we have 1 or more of these course purchase objects, we return true. It's pretty unlikely that we'd have more than one, but this logic seems to make more sense for right now, so I just left it in there as that. Now that we have this endpoint, we need to update our middleware. We'll start with the route middleware. And we're going to rewrite this one a little bit. We need to make sure to make this one async since we are going to make a fetch to this has access endpoint. And remember to pass in those cookies as the header. Otherwise, this has access will always return false because there's no session associated with this request. And so then we check to see if we have access. And if we do, we return because everything's good. Otherwise, we want to handle this interesting edge case here where the user has logged in with GitHub, but their GitHub account does not have access to the course. In that case, we want to immediately sign this user out. If we don't, they will get caught in this weird in-between state where they're logged in, but not really logged in because although they're logged in with their GitHub account, they won't be able to access the course. Now, ideally, we would provide some sort of useful error message here or special sort of screen where we can indicate to the user that they were successful in logging into GitHub, but their GitHub account does not have access to the course. Here, we're just logging out, which causes you to be redirected right back to the login page. But it's good enough for now. The next thing to do is to update our server middleware. And so for that, we need to update our protect route file here. And for that, we're going to follow very similar logic. First, we check to see if the user is logged in. And if they are, we make this fetch call. Remember, this one will be done entirely within the server without going through the HTTP layer. And then if we have access, everything's good. But if we don't, then we throw this 401 error. And here we don't need to worry about logging the user out because the route middleware will handle that for us. If you have an active GitHub session and you are making a call to this endpoint that doesn't have access, then you'll just get this 401 unauthorized, which is the same as if you weren't logged in at all. And so I don't think you can really get caught in an in-between state in the same way as with the route middleware. So I see no need to handle it in a special way. All right, so now that we have all of this set up, if I refresh my page over here, we can see that as we click through and into chapter 2, I still have access to the course, as I should. If I go into the Mastering Nuxt database here, if I flip this from verified to unverified, or I flip the verified Boolean to false, then as I click through, we're able to load chapter 1 because we're making this one available. But as soon as I click into chapter 2, we're going to be logged out because we don't have access. So I'll flip this one back so we can log back in. And there we go, we're back in. Now we have our whole checkout process complete from beginning to end. We create that course purchase object in the database. We wait for the Stripe webhook in order to verify, and it lets us know that the course purchase has indeed gone through successfully. Then step 3, we hook up our GitHub account with this course purchase object. And finally, in step 4 in this lesson, we saw how we can update our middleware to check for that course purchase object to make sure that this GitHub user indeed does have access to our course. In this chapter, we saw how we can take our landing page and use pre-rendering to make it even faster. We then added on optimizing our images through the different ways that we can manage our static assets. We looked at route rules. We looked at how we can configure our application using runtime config and app config. And then we finally integrated our checkout process with Stripe. And now we're able to grant access to users who actually pay for the course and not just anyone who happens to have a GitHub account.